Welcome to the Explainer. So, we're all living through this massive AI gold rush, right? Well, today we're going to look past the gold itself and talk about the picks and shovels. We're going to figure out why one company seems to be supplying, well, all of them, and why the real prize in this whole thing might not be what you think at all. I mean, make no mistake, this is a full-blown industrial revolution, all driven by AI. But, if you really want to understand who's winning, and more importantly, why they're winning, you have to look beyond the flashy AI models. You've got to dig into the hidden physics and, the economics that are really running the show. All right, let's get into it. Okay, so first things first, we have to wrap our heads around the sheer scale of the demand for AI computation. And look, this isn't some slow, steady climb. We are talking about a straight-up explosion in how much computing power we need. And it's happened like overnight. And that number you're seeing, it's not a typo. Experts are estimating that the demand for what's called AI inference, you can basically think of it as AI thinking, is about to jump by 1 billion times. 1 billion with a B. It's just a staggering number. And this incredible leap, it's all because of 3 new rules that have completely changed the AI game. So for a long time, the focus was really on the first law, right? Pre-training. That's basically where the AI just memorizes a ton of information. Then you had post-training, where it practices a specific skill. But the real game changer, the thing that's causing this billion-X explosion, is that third law. It's all about this brand new way that AI does inference, or thinking. Think about it like this. We've completely changed what we're asking the AI to do. It used to be all about the one-shot answer. You ask a question, it spits back a quick reply from its memory. Simple. But now we're demanding that the AI actually thinks before it gives an answer. It has to perform these complex chains of reasoning, go out and research stuff, check its facts, and even improve its answer as it goes. And that right there perfectly sums up the new rule of the game. The longer the AI thinks, the better the answer gets. Simple as that. The only catch? This incredible new skill comes with a massive price tag, an almost unimaginable amount of computing power. Okay, so demand is skyrocketing by 1 billion-X. How in the world do you even begin to meet that? Well, companies are building these gigantic AI factories. But here's the problem. They run headfirst into a hard physical limit, a wall, and it changes absolutely everything. The product that comes out of these AI factories is measured in something called tokens. A token can be a word, part of a word, maybe a pixel in an image. You can even think of it as a single unit of thought. And here's the crazy part. The global demand for these tokens, it's doubling every couple of months. The pace is just relentless. But, and this is the most important part of this whole story, these AI companies are power limited. The amount of electricity they can physically get to their data centers is a fixed number. It's a hard cap. You can't just wish more power into existence. And that creates a really simple, almost brutal equation for every single company playing in this space. If your goal is to make more money, you must squeeze the absolute maximum number of tokens out of every single watt of electricity you use. Tokens per watt, it's not just another metric on a spreadsheet. It is the most important number in the entire industry, period. So you have this massive problem, and this is the puzzle that NVIDIA decided to tackle. But here's the thing. Their solution wasn't just to sell a faster chip. No, they went way bigger. They completely reinvented the entire data center, transforming it into one single hyper-efficient machine, what they call an A factory. See, the old playbook for getting more computer performance is it's done. For decades, the whole industry relied on Moore's law. The idea, just shrink the transistors on a chip and boom, you get something faster and cheaper. But that well has run dry. The gains just aren't there anymore. So what do? If you can't make the individual chip faster, you have to think differently. You have to innovate outside the chip. The new goal isn't making one component faster. It's making the entire system faster. And you do that by optimizing everything, all at the same time. This whole approach has a name, extreme co-design. And it is a total break from the past. It means you design the hardware and the software to work together in perfect harmony right from the start. They're not separate things. They're one unified system. Every single part, the GPUs, the CPUs, the networking cables, the software that runs it all, everything is built to squeeze out every last drop of performance. And the result? This is how NVIDIA pulled off a mind-bending 30 times performance leap in a single year between their Hopper and Blackwell systems. 30 times. Moore's Law could never, ever do that. Okay, but here's where it gets really interesting. This obsession with efficiency doesn't just change the technology, it completely flips the economics of the entire industry on its head. Let me show you what I mean with a quick thought experiment. So let me ask you a question. Why on earth would a company turn down a free chip? I know, it sounds crazy, right? But remember, in this new world where power is the bottleneck, the sticker price of a chip, it's not the most important cost. It's not even close. So just imagine a competitor comes to you and says, hey, here's our chip. It's free, zero cost. Great deal, right? Well, maybe not. Let's say that free chip, because it's not as efficient, can only generate 1,000 tokens a minute using your limited power budget. Now let's look at the expensive NVIDIA system. Because it's so hyper-efficient, it can pump out 30,000 tokens a minute using that exact same amount of power. So by taking that free chip, you're actually losing out on the revenue from 29,000 tokens every single minute. And that is the entire ballgame right there. Your power is fixed, so the opportunity cost, the money you're not making by using a less efficient system, is, in the words of Jensen Huang, insanely high. It means you don't really have a choice. You have to go with whatever gives you the highest performance per watt. Anything else is just lighting money on fire. So, what's the big takeaway from all this? In the AI revolution, the ultimate currency isn't dollars. It's not the upfront cost of a chip. The ultimate currency is efficiency. It's the total output of your entire factory. It's all about one thing: maximizing your tokens per watt. So we've established that today, power is the great bottleneck. Electricity is the new gold. But as AI keeps automating intelligence, it makes you wonder, what's next? What will be the next truly scarce resource that puts a limit on progress? That's something to chew on. Thanks for joining me for this explainer.